Now, let's start now. The continuity. Continuity, we say that the function is to be continuous if the function or the limit of the function from the left is equal to the limit of the function from the right. That means the limit is existed, and the f of x, the value of the function, is existed or it can be defined. And the third condition was that the limit is must equal the value of the function. Now, these three states or these three graphs here are the states that the limit or the function is not continuous. Look at the first one. At the first one here, the function x at x equal a, limit x when x approaches a, or limit f of x when x approaches a. Look at x from the right, and it's equal to b, and x from the left is also it's b. So they are existed, or the limit, sorry, is existed, because the limit from the right is equal to the limit from the left. But what about the value of f of x? Did we have here any closed circle?
No.
No. So I will say now in this graph, the function is not continuous. Now look at the second one here. In the second one, here we have C and here we have A, or B. And limit f of x when x approaches B, when x approaches A from the right, you will say A from the right, you just draw an asymptotes, you look at the right, you will see it is C. And limit f of x when x approaches A from the left. Now, where's A from the left? It's close to B. B. Now, is C equal to B? Is the limit here exist? No. So I will say here also, this is the second condition where the limit is not, yes, the limit or the function is not continuous. The first one, yes, it's existed, but there's nothing about the value of the function is not defined. The second one, the limit is not existed. So I will stop. I will say now the function is not continuous. And in the third one here, yes, the value of the function f of x, it's defined, and the limit also is defined and it exists. But is the value of the function equal to the limit?
No.
No. So also this is the third condition that here I will say now the limit does not exist. Now here f of x, let f of x, it's x squared minus 4 over x minus 2 if x is greater than 2, and 5x minus 7 is x is less than or equal to 2. I want to check now if f of x is continuous at x equal to. So to find or to check if the function is continuous, I need first to find f of 2. F of 2. I will look at where's x is equal to 2. Is it on the first or on the second one? I have an equal sign.
Second.
The second, yes, here we have an equal sign. So I will say 5x minus 7, which is 5 times 2 minus 7, which is equal to 3. So the first one, it's yes, it's defined. Now, look at limit f of x when x approaches 2 from the right. Now, where is 2 from the right? That means x greater than 2. Which function I have to use? The first one. So I will say now it is x squared minus 4 over x minus 2. 2 squared 4 minus 4, it is 0, and 0 over 0, I have to what? To take an action. I have to simplify. I will write it as x minus 2 times x plus 2 over x minus 2. Then after that, now limit x approaches 2 from the right for x plus 2 is equal to what? 2 plus 2, it is 4. Then I have to find now limit f of x when x approaches now 2 from the left. Where is 2 from the left? Which function I have to use now? 5x minus 7.
second function.
Yes, the second. So 5 times 2 is 10, minus 7 is 3. Now, is the limit from the right equal the limit from the left?
No.
No. Since now the limit is not exist, so I will say here now, since the limit is not exist, so function f of x is not continuous at x equal to. Now, let f of x equal ax squared plus 3x if x greater than 1, 5bx plus 4 if x less than 1, and 2b if x equal 1. Find the values of a and b that make the function continuous. So if the function is continuous, that means the limit from the right equal the limit from the left equal f of x. So let's find now limit f of x when x approaches 2, not 2, 1 from the right. 1 from the right, that means x is greater than 1. So I will use this function. A x squared plus 3x. A times 1 is a, so a plus 3 is equal limit f of x when x approaches 1 from the right. Now then, limit f of x when x approaches 1 from the left. I told you that the limit from the right is equal the limit from the left and is equal the value of f of x. So it's equal limit f of x when x approaches 1 from the left, which is 5. So I have to use this function, 5bx plus 4. Or you can say 5b plus 4 is equal limit f of x when x approaches 1 from the left. And since the right is equal the limit from the left, so that means I can say now that a plus 3 is equal to 5b plus 4. Then, so a now is equal to 5b plus 4 minus 3, so a is 5b plus 1. Then, the limit, yes?
Why do you put a plus 3 equal 5b plus 4?
I just make a minus 3 minus 3.
بس ليه حطيتيهم equal لبعض؟
Because the limit from the right is equal the limit from the left. Since it is continuous, so the limit f of x from the right is equal limit from the left.
Okay.
And like go back. In the previous questions, we check if it is equal. If it is equal the value of the function, we say it's continuous. Here I told you it's continuous. So by default, the function will be defined and equal the limit f of x from the right and from the left. Then, so f of 1 it will be 2b. So because of that now, I will say that now that 2b is equal to a plus 3, and it could be equal to 5b plus 4, because the limit x from the right is equal limit x from the left and equal f of x. All of them have the same value. So 2b, I can say it's equal 5b plus 4. Do you understand why? Why can I say the function is equal the limit from the left?
Because the three of them are equal.
Yes, because all of them, the three of them are equal. So that's mean I can use this one and this one. Then minus 5b minus 5b. So negative 3b is equal to 4. So b is negative equal negative 4 over 3. This is for b. And then, and also we said from here that from this function here, I mean, a is equal 5b plus 1. Can I substitute b now and find a?
Yes.
Yes, teacher.
So I will say now here that since b is negative 3 over 4 and a is 5b plus 1, so a it will be 5 times negative 4 over 3 plus 1, which is negative 20 over 3 plus 3 over 3, which is negative 17 over 3. This is the value of a. So a it will be negative 17 over 3, and b it will be negative 4 over 3.
Can you repeat it?
Which one?
Solve another
Yeah, the
example.
A.
How to find a? Okay. Now let me take this function. Now you know how can I bring b, okay? Is it clear for you?
Yes.
Okay. And what I did, or as I told you, that limit from the right is equal the limit from the left is equal f of x. These things happen if the function is continuous. So because of that now, I can say, or I can use limit f of x when x from the right equal f of x. And I can use limit f of x when x from the left equal f of x. And also I can use limit f of x when x from the right is equal the limit when x from the left. Because these three values, limit from the right and limit from the left and f of x, are equal, so I can use I can use now any of them. I can say limit x from the right equal f of x, and limit x from the left is equal f of x, and x from the right is equal x from the left. For this one now, I can use them to find any missing number. And the two missing number here, or the two missing variable, it was a and b. Now, for the first one here, limit x from the right. We said that x from the right, it was, I deleted, yes. It was 2b, I think, when x equal 1. Now, x from the right, it is a plus 3. It must equal 2b. This is the first equation I have, using this one. Because limit f of x when x from the right is equal f of x. So 2b is equal a times 1 plus 3, which is a plus 3. This is the first equation I have. Now, the second equation here, which is limit from the left equal f of x. That's mean here what it was, not x plus 4, no, it was
5x plus 4.
5bx.
5bx.
5bx plus 4. So now limit from the left, it was 5b times 1, which is 5b plus 4 equal 2b. This will be now my second equation. And this will be now my first equation. From the second equation, can we find the value of b? Since we have b in the two terms. Yes, we just put 2b in the second term. So we say now 3b is equal, or negative 3b is equal to 4. So b now, it will be negative 4 over 3. This is a way how can we find b. So I found b. Now the second step I need now to find a. From where I find a? From equation number 1. From equation number 1, here we have a plus 3, I'm talking here, okay, equal to b. And b, I know the value of b, which is 2 times negative 4 over 3, equal a plus 3. Then after that, just do now the math. 2 times negative 4 over 3 is negative 8 over 3, minus 3 is equal to the value of a. So a now, negative 8 over 3 and negative 3 over 3, you can write as negative 9 over 3. Just make them with the same denominator. So the answer, it will be negative 17 over 3. This is the value of a. So a, it will be negative 17 over 3. B, it will be negative 4 over 3. And these, the values of a and b, makes the function continuous at f of x. Is it clear now?
Yes, teacher.
Okay.
Thank you.
You're welcome.